Hi, morning everybody, or afternoon. So I'm going to talk about the cake pattern in practice. And I'm working for KIXEYE, so it's a multi-game, massively multiplayer game. Okay, so what is the cake pattern? So, it's a software design pattern. It was first explained by Martin Odersky, and there was another paper on the web, which is pretty easy to find, by Jonas Bonér. And there's actually not that much on the web about it. So when you actually want to use it in practice, you have to, well, I've had to kind of make it up as I go along and make discoveries, and I'm hoping to share some of those discoveries with you today. So its real purpose is it's really a dependency injection, a way of doing dependency injection, and also arguably aspect-oriented programming, but some might dispute that. And it uses only Scala constructs, so there's no extra magic added into the language. And it's truly type-safe all the way through, and I don't think that's really true for many other DI frameworks. So the basic structure of how you use it, or starting block, is a component. So we have this, say we've got this type called foo, which is a great type. And we want to inject it into something. So in the cake pattern, we set up a container called the foo container component, and then I can define what foo is inside that trait. So it's a trait inside a trait. So it doesn't have to be like that, but it restricts how you use foo if you kind of force people to use it within the cake pattern if you have it defined inside. So in this particular case, I've got a val, so I can only have one instance of foo that I want to inject. So this is a implementation of this. So if I say I want to implement this foo component, and I'm going to call it the bar foo component, and this is something I discovered along the way. So I've actually created a trait for bar foo component and a companion object called bar foo component. So one of the biggest complaints about the cake pattern is that it creates boilerplate. So unfortunately, I'm creating even more boilerplate here, but it has a lot of benefits. So if we actually define here the list of other components that this implementation of the foo component actually uses. So I've created a type alias called dependencies. So it's pretty clear what it is. This is the list of dependencies, so baz and quacks, or whatever it's called. And here I'm actually defining the bar foo component, which extends foo component. And then we have this notion of the self type here, and this is where we basically define the dependencies. So rather than list them all here, I've already defined them up here, so there's kind of a connection there. And then I've defined the actual implementation of foo with bar foo, and just to show that these dependencies can be used, I'm just calling the hash function on the two dependencies there. And it's also important in this particular case where we're just having a single instance, we've got to have it lazy here. Now, the reason for the laziness is because the way you use these components is you have to mix them in to make up some super object. But the actual order in which those things are mixed in is you don't want to depend on that, because that's going to cause all sorts of problems. So by having it lazy here, we have all these dependencies lazily available, and then they should pick them up in the right order automatically. So while you've got that particular implementation in your mind, I'm going to show you how you can easily mock this. So one of the reasons to have dependency injection is because you can mock all the dependencies. So in this case, I want to test bar foo component. So I know that it depends on backs and quacks. So I create two mocks for those two dependencies. And now when I'm testing it, I merely have to call foo.hash function. Now that's going to force the lazy evaluation, which is then going to call baz and quacks. So I now verify that those two have been called. So it shows how easy it is to mock the dependencies. So how do we put this all together into a big application? So I've done it in 2 steps in my applications. First, I have this concept of a module. So a module is basically a collection of related components. So, say you have a database component, that you may have a particular Postgres or MySQL, and then various other transaction components that form a natural grouping. So a module is a grouping of components. So in this particular case, I've got, I'm defining the bar foo module as being bar foo, dib baz, and dob quax component all put together. And because I've defined these dependencies in terms of their companion classes, it's easy for me to just say what the dependencies are for these three components. I can basically say it's this dependency with these and with those. And you may choose to actually collapse that down into something more specific, or you can leave it super general like this. So if it's super general like this, if any one of those implementations is changed, then this doesn't have to be changed as well. And that's usually one of the problems with the cake pattern without handling dependencies like this. It can be very difficult to, you have to copy and paste all those dependencies all the way down the chain, and this kind of avoids a lot of that. And then once you've defined all these modules, defining the way in which you put in all these components together, you want an application context, which is basically a collection of all the modules that make the application. And so this is an application context in the same sense as you would in Spring, for example. So at this stage, you should be having a class. You shouldn't be a trait, all right? So there shouldn't be any dependencies left at this point. This is a fully defined application context, and you should be able to run the program at this point. And so I just showed in my initial component, it just had a val. Now, the general pattern is that you have, foo component, and then inside you define something called foo. Now, the type of that foo and how it is set up can vary, and that's where things can get really interesting. So by having a val here, I'm essentially setting up a singleton scope dependency injection. But if I change it to a def, which is how you actually usually people start with that as a way of explaining the cake pattern, but I'm doing it a different way. So if you do def, that means every time you call foo here, you're going to get a different, or you could get a different instance of foo. So this is no scope in this case, because you're basically throwing them away every time you're getting them. And how do you get any kind of intermediate scope? So I came up with this other idea of having a with something component. So in this particular case, the idea is you have with foo component, and now we can kind of have a narrower scope somewhere between singleton and no scope. So we can have, and then because it's with foo, then we got to have a with foo whatever. In this case, it's a method, and it takes a call by name. So it takes a block of code, which is taking foo to something else. So we can use that. So in this way, we can control that foo. We can create it and destroy it at the end of this code block. And we're controlling the scope of that foo. So that's one way of doing sort of a sort of restricted scope. Another way is using implicits. So this is what I call a session scope. So in this particular case, we've got a foo, which is a method inside the foo component. But in this case, we're expecting an implicit session parameter, perhaps. And so you can obviously see how that would be useful in a web application. This way, every time. So we have an implementation as an example. So the foo, we could have an implementation called bar foo, and then bar foo takes an implicit session. And basically, so in this particular case, we're getting a new instance of bar foo being instantiated every time, but it may get the same session in multiple different calls. And you can obviously optimize that by making this whole thing more complicated, but I wanted to keep it simple in this talk, or simple-ish. And, oh yeah, AOP. So, yeah, so this is kind of extending the with notion. So I've got a with transaction component. So obviously I need a with transaction in there that I'm injecting. So in this case, it's similar to the session scope. So except in this case, it's a block of code which doesn't take any, it's just executing some block of code within this with transaction. This is a bit like a DSL for transaction, but in a cake pattern style. So, arguably, some might say this isn't AOP because, I'm not truly doing an independent point cut outside of the application. But, there is if you look at the way you can do it in Spring, for example, you can have an @transactional, which is, an annotation-based AOP. So you can see that there's a parallel. In the cake version, you would just say, I've got my method, and I just say with transaction, 1 plus 2 will be done within the transaction. Whereas in this case, we are just annotating the method with @transactional and expecting something externally to, to put a wrapper around that and make sure it's a transaction. So if you were testing this, you would obviously want to make, say, a with no transaction component, for example. If you just want to test, the 1 plus, make sure the 1 plus 2 gives you 3, you don't care that it's in a transaction. So you can kind of null out the you can mix in a with no transaction component into this, so that this actually doesn't do anything in your test. Okay, so this is another use case. So time itself is, interestingly, that's a side effect. So in a sense, time itself is not really a good thing in functional programming. So that really is out of touch with reality, really. But, so obviously you want to be able to inject a clock into your application. You probably want to try and be able to control it. Otherwise, it's very difficult to have tests which have got different times every time. So I've got a clock component here. And in this case, I might want to have an implicit val clock. So if I've injected this or mixed in this clock component into some part of the application, then I can automatically pick up the clock and read the current time. And I can obviously create mock implementations of this, but I've got a system clock implementation of this, which extends the clock component. In this case, the clock is equal to system clock. And in this case, I haven't put lazy on because it's not actually depending on anything else, so there is no possibility of a race condition here. Now this is a kind of a special component that I have in my systems, and it's not really a component, but I mix it in with all the other components anyway. So this is a way in which I can have setup and tear down. Because sometimes when you want to inject something, there needs to be something done at setup and something done at tear down for that component. Like the actor system, for example, you might want to shut it down at the end, for example. So I usually mix in this or into the components that require some kind of setup and set down, and then they can call a setup hook and a teardown hook, which gets essentially added to the queue of things that need to be set up and torn down. And then there's actors. So actors throw in, a little bit of a confusion into this whole thing. So say I've got a foo actor, so I define an actor. And so I've done this kind of cake pattern in a slightly different style. Well, it's not really a cake pattern, but I'm taking the actual cake pattern context, the whole application context, and I can throw it into the actor, into the actual constructor, and I just call it injector. And then its dependencies are foo actor dependencies. So I can say the foo actor depends on bar component. And so I'll move on swiftly because we're running out of time. So the actor props component, so this would be, there are different ways in which you instantiate the actor. So, we have this notion of props. So one of the funny things about actors is that they're really great in many ways, but one of the ways which kind of puzzles me a little bit is there's actually quite a lot of type safety kind of lost in the actor system. So you see here props, and it could be anything. But I'm notionally thinking that this is a foo actor being in this props. And then when you actually instantiate the props, we've got two different ways. Well, there's the recommended way, which is to do class of foo actor and then pass in here, which this could be anything. It doesn't actually have to, the foo actor doesn't have to have a constructor. This is basically type unsafe or not type safe, whereas if you do it this way, which is now considered deprecated, it is type safe. So I don't know. I think there's definitely a solution required there. Then there's the TestKit. So I'm just showing how we can test the actor using the actor TestKit. So I think I'll have to skip through that, but it'll be on my slides, which you can look at on the website afterwards. And then there's the actor component. So maybe you want to instantiate an actor. So obviously, to instantiate an actor, you need to have other dependencies, such as an actor factory. and setup teardown. So this was an example of how I'm using setup teardown. So you can see here I'm setting up the actor, because this actor is lazy. I've added a lazy val, so that means when you start up the system, this actor isn't actually running. So you do a setup hook, which just can call any method here. It could be toString. Just the fact you're referencing it forces it to become not lazy anymore at this point and actually evaluated. So the actor will start running. And last slide. Yeah, so KIXEYE, massively multiplayer online games. You can join our team of Scala server developers if you want. My name is Peter Potts. I'm principal architect, and that's my email address. Any questions?
Yes, so is there a difference between the cake pattern and the thin cake pattern?
And the which?
Thin cake pattern?
Thin cake? I haven't heard of the thin cake pattern. I'll have to look that one up. I don't know that one. Well, actually, in many, he's asking what the use case for a singleton pattern. I mean, there are a lot of use cases for singleton pattern. I mean, starting up a web server, you're only going to have one HTTP server, right? You mean, why would you want to have a single, as opposed to having an object, for example, you mean? Or then you wouldn't be able to inject in mock dependencies. So you want a way of having only one instance of something in runtime, but you want a way in which you can inject other things into it in a test. Is that what you meant? Well, if it's def, for example, instead of val, then you are potentially instantiating a new one every time. So, which maybe you want that in the tests, and maybe you don't want it in the. So you could define it as a def, and then in the actual implementation make it stricter. So you could have it def in the actual, like in here, for instance, you could have def foo, but then actually in the implementation you could still have a val, because that's just making it, reducing the scope, reducing the possibilities. So you could do that. But you can't do it the other way. So it's really just how tight you want to make. If you know that any use of that component is only going to need one, so like a clock, you're unlikely to have an application which has got more than one clock. Or actor system. It's unlikely to have more than one actor system. Or web server, or even database. Well, you might. But then you can always have a def, and you can have a function, and pass in a string, so you can then pull different named versions of that component, for example, like you would in Juice, like named. Okay. Yeah, finished.
All right, thank you, Peter.